Hi everyone, Hossein is here from EJ Academy, and Amir also is here today. Hi Amir, how are you today?
I'm good, thank you. How are you?
I'm good, thank you, thank you.
Mm,
So Amir, I have a calculus problem for you. This problem is about limit, and so basically it's one of the limit applications.
mhm,
So in this problem, we wanted to look at a ratio, and this is a ratio of exponential function to a polynomial function. As you can see on the screen, this
mhm.
is a limit of e to the x to x to the n. And so you're going to use limit concept and show us when the limit of this fraction when x approaches infinity is infinity.
Yeah,
Yeah.
yes, yeah,
So the floor is yours. Go ahead.
yeah, thank you. And the implication of that is also interesting to me because uh, it says that it shows that the exponential function approaches infinity faster than any power of x. In other words, if we have two functions, f of x and g of x, and if we are asked which one grows faster, we can use limit of f over g when x approaches to infinity and see which value we get. So
Right.
that determines the rate of the growth when we want to compare the rate of the growth for two functions, f
Right.
and g of x. Here we have a exponential function and a polynomial function.
Right.
So since that's a limit problem,
Mhm.
uh, we can look at the form of the value of the limit. Okay, here limit of e of x over x to the power of n when x approaches to infinity. And we know that the n is a positive integer, which is
Right.
very important here. So
Mhm.
it gives me e to the power of x when x approaches to infinity is infinity. I think in previous video we showed that in a graph, when we have e to the power of x.
Yeah, we will
Uh,
post the link for that video up here,
yes,
so
yeah.
the viewers can review that.
And the numerator is infinity and the
Mhm.
denominator is also infinity. So we have an indeterminate form because, the indeterminate forms, we have two famous indeterminate forms. Uh, one is 0 divided by 0, and another one is infinity divided by infinity.
Correct.
So, and when we have one of these indeterminate forms, we can use uh, Loopital rule.
That's
Uh,
correct.
in other words, let me just write it down. Uh, the Loopital rule is like this. When limit of f of x over g of x, when x approaches to a, any number, or infinity in this case,
Mhm.
uh, if the answer is one of these two forms,
Mhm. 0 over 0 or infinity over infinity.
yes, we can look at the differentiation of numerator and denominator.
Mhm.
F prime of x, if a prime here is actually a derivative of f with respect to x,
Right.
and g prime of x when x approaches to a. And again, if the result of this limit is one of these indeterminate forms, we can use the Loopital rule for the second time.
Right.
So let me just write it here. I call it H. It means that from moving from left to the right, I use Loopital rule. Again, I use Loopital rule here. So
that means there is no limit, in terms of the number of times you can use Loopital rules.
yes, as
As
long
long
as
as you get indeterminate forms that you wrote up there.
yeah,
Yeah.
that's absolutely correct.
Okay.
And so I can use it many times, until I get until I get a determinate form.
Correct.
Which is like a number divided by 0 or 0 divided by a number,
Right.
So given that Loopital rule, I'm going to use that for this function.
Mm-hmm.
So let me just write it down again. X approaches to infinity. So here I use Loopital rule. Okay, we are familiar with the derivatives of these two functions.
Right.
The
Yeah,
derivative
pretty
of,
straightforward.
yeah, the derivative of e to the power of x is again e to the power of x, and the other one, the denominator is n x to the power of n minus
Yeah.
1.
Yeah, this is the derivative of a polynomial function.
Yes, yeah.
Yeah.
And okay, when we actually replace x into denominator and a numerator for the infinite value, we again obtain this indeterminate form.
Right.
Infinity divided by infinity. So it means that I still have that indeterminate form. So I'm going to use the Loopital rule again. So for the numerator, the derivative of e to the power of x is again the same. For the numerator, I have n times n minus 1 x to the power of n minus 2.
The second derivative of that polynomial function.
Yes, yeah, that's the second derivative because we are using the Loopital rule for the second time. And again, we have in the numerator, we have again infinity. In the denominator, we have again infinity as well. But it seems that the order is reduced by when we take a derivative, the order is reduced one time by one value. So as long as we have x in the denominator, we have that infinity. So
Right.
it is better to get rid of x by taking derivatives as much as we can.
When you say the order is decreasing, you mean the order of the denominator?
Power, yeah, the power of.
You're talking about the denominator.
Yeah, denominator.
Yeah.
Yeah, correct. I'm talking about the denominator and the power of x. So yeah, so let me, I mean, if I take another derivative, so I'm gonna have like, n times n minus 1, n minus 2, n minus 3, until I get, like 2 times 1.
So if I understand correctly, you're trying to take as much as derivative until you reduce the power of x
to 0.
To 0.
Correct.
That means that you're applying, I don't know, you're applying the L'Hopital rule n times.
N times, something like that, yeah.
Right, okay.
So I use L'Hopital rule for many times here.
Because as long as you have x in the denominator,
yes,
you're going to get indeterminate form.
Yes,
so you're going to get infinity divided by infinity.
We are screwed as long as we have x in the denominator. So I'm going to, let me write like this, e to the power of x, n times n minus 1, n minus 2 and other terms until we get like x. Yeah.
Right.
Let me write like this. I think it's
two times x.
2, yeah, times x.
Yeah.
And x approaches to infinity. So it means that we still have x in the denominator, but that's the last time that we use the Loopital rule.
So up to this point, you use Loopital rules n minus 2, n minus 1 time.
Yeah, correct. It doesn't matter how many, it's better not to get confused with that. It doesn't matter. It just,
yeah, it doesn't matter. Right.
Yeah, it doesn't matter
Yeah.
for the answer. So as long as we, get rid of x in the denominator, we are good to go. So for the last time, I use Loopital rule. Yeah, luckily for the numerator, it's the same. It's easy. And this one is going to be 1, yeah, when we take the derivative.
Right.
So
it's going to be the one that you wrote in gray up there. It's going to be exactly that.
Correct. Yeah.
Those terms. Yeah.
Here.
Yeah.
Oops. Go back to pen. N minus 2 times 2 times 1. And yeah, we know that for any positive integer, this is the denominator is a definition of the factorial of n.
Correct.
Correct. Let me write it better.
Which is basically a number.
Yeah, a number. Correct. So it's independent of x. So we don't have x anymore.
It's a constant. Yeah.
It's a constant. Correct. So it is, as you mentioned, is a constant. So that's a good news for us in the limit sense.
Yeah,
because
we got rid of the x.
Yes, we got rid of x. We don't have this indeterminate form anymore. So the answer of the limit, at this point, we just can, plug in the x value to the limit function. So it is going to be e to the of infinity divided by n, a factorial of n. Numerator is infinity, which is infinity. And when I don't write the sign, it's positive. So I just showed that the answer is actually infinity in here.
Yeah, that's correct. That's correct. Thanks, Amir.
Sure.
Yeah. So to summarize, to find the limit of this function, you first, obviously you plug in the x, and then you found out this is an indeterminate form. And because of that, you can use Loopital rule. And so you use Loopital rule down below. And so your goal was to get rid of the x because you saw that the power of x is reducing when you use it for the first time and second time. So you use it as many as times that you could get rid of the x in the denominator. And finally, I think the last step, you got a constant in the denominator. And
correct.
And so then you plugged in the x, which was infinity, into the the fraction. So you got infinity divided by a factorial of n, which is a constant. So the answer is positive infinity. And that means that the exponential function grows faster than polynomial function when x approaches infinity.
Correct.
Yeah. All right. Thank you so much.
Thank you for explaining
really appreciate it.
Yeah,
Yep.
sure.
Yeah. So for the viewers, that was it for today. If you have any questions, don't hesitate to leave a comment or questions below this video in the comment section. And if you learn something from this video, please hit the like button. That is going to encourage us and help us to motivate to make more videos like this in the future. If you wanted to get notified about future videos, hit the notification bell. And till next video, bye everyone.
Bye. Thank you.